Hello world, my name is Victor Engelmann, and in this video I want to show you the Raspberry Pi Pico. The Raspberry Pi Pico is a very small little computer and a very weak computer, I should say also. You cannot do much with it, but you can program it, and it's very cheap. So when it was introduced to the market, I think it cost around $3. And yeah, I really couldn't resist something that is programmable and costs next to nothing. So I ordered one on Amazon, and I ordered it with a USB cable and also with legs. So that drove the price up a bit. So mine cost I think 13 euros. And yeah, it has legs, but it came with the legs separately. So yeah, the first thing that I need to do now is solder these legs to the Raspberry. Now, please don't be too harsh on me. This is really just the second time that I ever soldered. So that's really not something I regularly do. So I'm not gonna do a very good job here. And I only have a starter set for soldering, but okay. What I'm doing here is a trick that I've learned from Adrian's Digital Basement. I'm putting the legs into a breadboard so that they don't move, and then I put the Raspberry on top of it, and then I can solder them. With the soldering iron, I heat up the pins and then put the soldering mass to it so that the pin melts the soldering mass, and then the soldering mass flows onto the pin. I've heard that you should do it this way because it's not really good for the soldering iron if the soldering mass goes onto it, and if that happens, you can clean the soldering iron with such steel wool here, and also the connection between the soldering mass and the pin is apparently better when the pin is heated up. So the two substances make a better connection. Okay. And every time I've finished soldering one pin, I will skip over a few pins so that there is no pin that has a constant exposure to heat for a long time. So when I have soldered one pin, there's a lot of heat already on the neighboring pins, so that the neighboring pins can cool down while I'm soldering other pins. Here I made a mistake. I've put too much soldering mass on it, and now there's a connection between two pins. So what I'm doing now is I'm heating that soldering mass up again, and once it's liquid, I then remove it with a desoldering pump. Okay, and now I also have to attach these additional 3 pins here. Okay, so now I'm finished soldering it, and okay, it's not perfect, but given how little experience I have soldering, I'm quite satisfied with the result. Okay, so now of course you want to do something with your Raspberry Pico, and how can you do something with this now? So as I said, I have this USB cable here, and that's attached to my laptop, and if I plug in the other end into the Raspberry, then it powers up and starts executing the software that's on here. And the question is now, of course, how do we get software onto this? And for this, the Raspberry Pico has this little white button here next to the USB connector, and it's labeled boot cell for boot selector. So you have to press that button and then plug it in. Okay, so what it does now is when you press that button while you are powering it up, in that case it doesn't start running its software. It then talks to the USB connection and says, "Hello, I'm a USB thumb drive or something." So as you can see, I can now open this and have this text file here, and now you can put software just into this window here. And for example, I have prepared this file here, blink.uf2. Okay, so I now copy that and paste it in here, and as soon as I paste it here, the window disappears, so the Raspberry immediately disconnects and starts executing the software that I've moved onto there. Okay, and as you can see, I don't know if you can see that, it is blinking now. It is blinking now, and that is exactly what this blink program here is supposed to do. Okay, so the next question, of course, is how do you generate a program? I mean, you want to program this thing yourself, so it doesn't help much if you just have this blink.uf2 file. You need to know how you can write such a program yourself, right? Okay, so just a quick note here. I want to program the Raspberry using C and not Python. There's a lot of tutorials out there that show you how to program it in Python, and they use something called MicroPython. I don't know if that's a compiled language, but I don't know. It just doesn't feel right for me to program such a low-level device with a high-level language like Python. So I wanted to use C. And for that, I can really recommend this PDF file here on datasheets.raspberrypi.com/pico/getting-started-with-pico.pdf. It has a table of contents here, and it really goes into a lot of interesting topics that you would be interested in. So the first thing that you need to do, install an SDK. Then it's about building that program that I just showed you for blinking, and so on. So there's a lot of interesting stuff here, but let's go into the part about the SDK. Okay. So what it tells you is that you need to clone these Git repositories here, one with a Pico SDK and one with examples. Okay, so let's just copy and paste this. Okay. So I copy and pasted this command to clone the SDK. Then we need to go into that directory and run git submodule update without the dashes. And with dash dash init. Okay, now let's go back one step and also check out the example files. Okay, done. Now it tells you need to install a few things. So you need CMake. I have already installed it, so I'm gonna cancel this. Oops. Then it tells you to install gcc-arm-none-eabi. That's a cross compiler for this processor. I've had quite some trouble doing that because on my Manjaro machine here, the package is named differently. So I think it was named ARM none eabi. Yes, right, GCC. Okay, and then I would also need, so on Manjaro you have this this part ARM none eabi as the start of the name of the package and then GCC after that. And corresponding to that, the next package is ARM none eabi dash lib okay, that was the name. It wasn't ARM none eabi lib new lib. It was just ARM none eabi new lib without the lib before new lib. Okay. And then it also wants build essential. I don't think I've installed that. I think that was this binutils package here. Okay, so these are the ones that I installed here on my Manjaro system, and yeah, then we are already in chapter 3, which is already about building this blinking program. So for that you can go to the Pico examples directory. In here you can then create a directory. You can name it any way you want, but I would call it build. Go into that directory, and in here you can then run cmake ... So this then runs cmake for this cmake lists txt in the Pico examples directory, but the files that you generate are then stored in build, so that it doesn't pollute your source directory. Okay, we need to specify a environment variable. So we need to set this environment variable and set it to the location of the SDK. Okay. So now we can cmake run the examples directory. This has created a lot of files, and one of the files that it's created is this make file. So we can now run make in this directory, in this build directory. And yeah, now it's building, and this will take a while. So I'm gonna fast forward here now. Okay, it's finished building. This took quite some time, but don't worry, a lot of the time was spent on compiling SDK components. So when you compile again, it will not take this much time anymore. And also I have compiled all the examples now, and you don't need to do that. You can, if you look into the directory here, you see there is a subdirectory blink and a subdirectory hello world and so on. So you can just go into one of these subdirectories. In here you will also find a make file. So you can run make in there, and then it will only build the one example that for that directory. Okay. Of course, I've just built this project, so it doesn't have to do anything at this point. Okay, so let's look into this directory. Okay, my programming Pico directory, Pico examples, build. This is something that I often forget, so I will go into the blink directory instead of the build blink directory, for example. And yeah, here's your blink.uf2. So now you can take that and put it on your Pico, and then your Pico will start blinking. Now let's look at the code for this blinking. Okay, so it's here in Pico examples, blink. And yeah, this is really very much like programming these GPIO pins. This LED has its own GPIO number, and yeah, here you request access to that pin. You tell it to use this pin as an output pin. You know, you can set a pin to input or output mode, and yeah, if you turn it to output mode, then you can send data out through that pin. If you set it to input mode, then you can read data from the pin. And yeah, then in here, it turns the pin on, waits for a quarter second, then turns the pin off again, and waits another quarter second, and then repeats infinitely. So that's not so hard, right? So let's talk about something more interesting. Now we want to communicate with the program on this Raspberry Pi Pico. And yeah, chapter 4 is the typical hello world program. You know, while true, printf hello world, and then sleep for a second. But this printf, I mean, normally printf would talk to some background stream, you know. Internally it would use a system call, and then the operating system kernel would have to capture that call and do something according to that system call. But yeah, the Raspberry Pico doesn't have an operating system, so there is no kernel that you can talk to through a system call. So what you have to do instead is you have to call stdio init_all, and that configures some of the pins so that they can be used as a serial communication interface. Okay, and yeah, this this Hello World program, we've actually already built that. It's in our directory Pico examples build, Hello World, and there's these two subdirectories, serial and USB. And yeah, let's talk about this Hello Serial UF2. For this, I will power up the Raspberry Pico again, pressing the boot select button. So that I can flash it now again. And as before, I will copy the UF2 file and paste it here. Okay, so now the Pico isn't blinking anymore because yeah, the Hello World program doesn't tell it to blink. It tells it to send out Hello World over a few pins using a serial protocol. Okay, and yeah, that's the next topic. How can we now receive this data? And yeah, here in this table you see that UART0TX and UART0RX are the pins 1 and 2, and then you have another pin for ground is pin 3. And these are really the interesting pins that we need now. Let's scroll down a bit, and yeah, here's a little diagram of how you can connect this to a full Raspberry Pi, but that's not what I want to do. I'm going further down here to this diagram, or this image here, which again tells me pin 1 and 2 are UART0TX and UART0RX, and the ground pin. Okay, and yeah, as I said, you could connect that to a Raspberry Pi, but I didn't really want to do it this way. So what I did instead is I bought this little device here. That's a CH341A. That's a little device that converts USB to UART, or also I2C, SPI, and yeah, here's a part of the manual for this thing. So one important thing is you have this jumper up here, so you have 3 pins and one jumper, and you have to put this jumper either on these 2 pins or these 2 pins, depending on whether you want to communicate through I2C or SPI for these 2 pins, or UART for these 2 pins. Again, the configuration of our pins on the Raspberry Pico was a configuration as UART. So, so in my case, I have to put the jumper on these 2 pins here, on the right 2 pins, and then I have to connect these 4 pins down here to the corresponding pins on the Pico. So let's do that now. So I take 3 wires and put them in with these 3 pins. And now I have to check out the diagram again. Okay, pin 3, that's the black one, is the ground pin. And the ground pin is the lower right pin on this UART. So So black goes there. Pin 1 is UART TX. That's this gray cable here. And okay, TX is the third pin here, but with UART you have to be careful because it's actually the opposite of what you would expect now. You need to take the TX of the one device and connect it to the RX of the other device. So that's the second pin here. And the middle pin, number 2, is RX. That needs to be connected to TX. That's the third pin. Yeah, that's something that you need to be careful about with an UART interface, because RX is for receiving and TX is for transmission of data. And yeah, that's why you need to connect them to the opposite pin on the other board. You know, the data that is transmitted on one board needs to be received by the other port. So the TX of one board needs to be connected to the RX of the other board, and vice versa. Okay, so let's try this out. I had already put the Hello World program onto the Pico. The Pico is powered up, so it should be happily sending out Hello World to the serial interface. We are just not reading it yet. So the serial UART interface is connected to this board. Okay. Let's look into the kernel messages, and it tells me now that I've plugged this into my USB port, it tells me that it has found a new USB device, TTY USB 0. So what this means is that I now have a device file, dev TTY USB 0. Okay, so this USB 0 from the kernel messages is this USB 0 in my device files. Okay. And yeah, what this means, TTY USB 0 means that this CH341A device registers itself as a serial interface to the operating system. And this now means that we can communicate with that with any tool that allows us to communicate through a serial connection. And yeah, in the manual they suggest the program Minicom. I've already installed that, so it's already installed, so abort the installation. And now let's open a new terminal here. So now I can call Minicom, but to access this device file I will need root privileges, so PseudoMinicom. It communicates with a speed of 115,200 bits per second. That's also called the baud rate. So baud rate 115,200. this -o. I don't want to go into what that means, and dash capital D for the device file was dev tty USB 0. And there we are. Okay, now we are connected to this CH341A, and it receives the data from the Pico, and yeah, this is really awesome. So now I can quit this using Control-A, Z. You know, it's this prompt down here tells you Control-A, Z. And yeah, with X I can quit now. Yes, quit, and we are logged off. So yeah, now we can compile programs for the Pico, install them on the Pico, and communicate with them through a serial interface. I think that's pretty cool. But of course there's now infinite possibilities of what you can do with that. For example, just today I've stumbled across this article here where somebody programmed a Raspberry Pico to talk to a floppy drive. Yeah, so using a Raspberry Pico is a bit like going back in time. But anyhow, I've also read about an online simulator for the Raspberry Pico and some other devices. That looks pretty interesting. I haven't looked into that yet, but it looks pretty interesting. Also, I want to mention that this UART protocol that we've used here is a very, very common protocol in the real world. So a few years ago I've seen a video from a DevCon conference where a guy showed how he routed 20 devices in 45 minutes, and almost all of them were routed using a UART connection. You know, they would route security cameras, routers, DVD players, any kind of device that you can imagine, they routed them, and it was almost always using a UART connection. You know, they would just open the device and look on the board for for 3 or 4 pins, and then they would connect a UART like this one here to that, and then they would be able to connect to the device directly and have root access to the device or whatever. And some of them had a little bit of protection, but most of them didn't have very good protection against access through that UART connection. Okay, but yeah, I think this is enough for today. If you like this video, like it, share it, subscribe, and see you next time.